In this video, we're going to solve the rational equation x is equal to the square root of 6x minus 5, and we want to solve for x values where x is a real number. So the first thing you want to do when you're dealing with a radical equation is you want to isolate the term with the square root. Well, it just so happens that the term with the square root is already isolated for this problem, so we don't have to do any work there. So now we can go ahead to our step 2 in solving a radical equation, and that is to square both sides, because that's going to undo the square root. So whatever you do to one side, be sure you do to the other. So that's going to give us x squared on the left-hand side. On the right-hand side, the squared and the square root are going to cancel each other out, giving us 6x minus 5. And so now we don't have any square roots, but we do have an x squared, an x term, and a constant. So we're dealing with a quadratic equation. And whenever we want to solve a quadratic equation, looking back to last week's material, we just want to move everything to one side of the equation, set equal to 0, and then we want to factor and use the zero product property. So let's go ahead and move everything. I'm going to move it to the left-hand side. So I'm going to subtract 6x from both sides. And that's going to give us x squared minus 6x on the left equals negative 5. Then I'm going to add 5 to both sides. Of course, if you want to do those last two steps all in one, that's perfectly okay. So that we're going to end up with x squared minus 6x plus 5 on the left-hand side, and that's going to be equal to 0. And so now we want to look at how we can factor the x squared minus 6x plus 5. So we can factor that. Looking at our factors of 5, we have 5 and 1, and 5 and 1 do combine to give us a 6, so we're going to have x minus 1 and x minus 5. Because negative 1 minus 5 gives us negative 6, negative 1 times negative 5 gives us positive 5. And so now we want to set each of these factors equal to 0. So we'll start out with the x minus 1. So x minus 1 equals 0. We're going to add the 1 to the other side and get x equals positive 1. And that's our first solution. Now setting our second factor, the x minus 5 equal to 0. We'll do the exact same thing. This time we'll add 5 to both sides and we get x equals positive 5. So our two potential solutions are x equals 1 and x equals 5. Now the reason I say potential solutions is because whenever you're dealing with a radical equation, you always have to go back and you have to plug that value of x into the original problem and make sure everything works out, only taking into account the positive version when you take the square root or the principal square root. So let's go ahead and check the x equals 1. So if we plug 1 into the place of x in the original problem, that's going to give us 1 is equal to the square root of 6 times 1 minus 5. And now let's go ahead and simplify this. Nothing changes on the left-hand side. On the right-hand side, 6 times 1 just gives us 6 minus 5. So we'll have 1 is equal to the square root of 1. And of course, the square root of 1 is just going to be 1 because we only want to take the positive version there. And so 1 equals 1, that checks out. So x equals 1 is definitely a solution. Now let's do the exact same thing for x equals 5. Go back to the original problem before we made any changes to it and plug 5 into the place of x. That's going to give us 5 is equal to the square root of 6 times 5. Minus 5, and simplifying the right hand side again, 6 times 5 is going to give us 30 minus 5, and 30 minus 5 is going to give us 25. Again, we only want to take the positive version of the square root there. The positive square root of 25 is going to be 5, and so 5 equals 5, that checks out. So for this particular case, both x equals 1 and x equals 5 are our solutions. Now, if you ended up with some kind of nonsense like 1 was equal to 4 or something like that when you were checking your answer, then you would just discard that solution. But as long as everything works out, we include both solutions in this case because everything did.